This video is part 3 of solving logarithmic and natural logarithm equations. In this next part of our video, we're going to look at solving this natural base logarithm equation, very similar to what we've done before with our other logarithmic equations, or excuse me, exponential equations, except instead of base 10, we have base e for this equation. So what we're going to do first is I want to isolate this variable. To do that, we have to isolate this entire term. So I'm going to subtract 2 from both sides to start. So we're left with 4e to the 2x equals 14. Next, what I can do is I can divide by 4 on both sides. So e to the 2x equals 14 divided by 4 is 3.5. And now when this is in exponential form, I can take the natural log of both sides. So what I can do is rewrite this as 2x equals the natural log of 3.5. I'm going to now divide this by 2. So x is about, let's use the calculator now. The natural log of 3.5 divided by 2. 0.626. And if we were to substitute this back into our original problem, right, if I plug this into the calculator, 4e to the 2 times 0.626. I'm just going to add 2. We should get pretty close to 16. Again, this was a rounded number, and I rounded down, so this should be a little smaller than 16, so that's a pretty good solution. Let's try a few problems. What are the solutions of each equation? Again, I'm trying to get this variable by itself. This term is isolated already, which is good. So I'm going to take the natural log of both sides. When I take the natural log base e of this side, that will eliminate our e. We can write x minus 2 equals the natural log of 12, ln 12. It's almost as if I'm taking the natural log of both sides here, right? Because these will be eliminated, because the natural log ln is really log base e, and when you have the same base as our solution, that will just be our x minus 2. They're eliminated. So now to isolate the variable, I'm going to add 2 to both sides. So x equals the natural log of 12 plus 2. Natural log of 12 plus 2, x is about 4.485. On this next one, 2e to the negative x equals 20. What I can do first is I can isolate this term with the e by dividing by 2. So divide this by 2. We get e to the negative x equals 10. I can take the natural log of both sides. That will eliminate our e as the base, so we're left with negative x equals the natural log of 10. And then I can divide by negative 1 on both sides to get x equals the negative natural log of 10. So now in my calculator, I can say the negative natural log 10 is a negative 2.303. Rounded to the nearest thousandth place value. And in our last example, I'm going to subtract 5 from both sides to get e to the 3x equals 10. Again, take the natural log of both sides. So 3x equals the natural log of 10. And we can divide by 3 to get x is equal to natural log of 10 over 3. So let's plug that into our calculator. Natural log of 10 divided by 3, x is about 0.768. I'm just rounding to the nearest thousandth place value.